Hello everyone, hope you all are fine. Welcome to Saurabh Sir's classes. So today we are with again with tomato problem solving session, objective part. So as I have always said that tomato is an important, very important book for aspirants who are aiming for Indian Statistical Institute B Star or B Math examinations. So there are two types of questions in the book, so objective and the subjective. So we are back with the problem solving session of the objective part. We will explore topics, we will explore problems, and more importantly we will have intuitions and problem solving strategies. Okay, so this is the first question for today. Given A, B, C are real numbers, then x minus a whole cube plus x minus b whole cube plus x minus c whole cube has number of real roots equal to option A is 1, option B is 2, option B C is 3, option D is 0. It means that if A, B, C are real numbers, the main thing of the gist of the question is to find the number of real roots of this equation that is given, that is x minus a cube equals to 0, x minus b cube equals to 0, x minus c cube equals to 0. So I just give you the stipulated time to solve this question. I hope that you will see it now. Okay, so the stipulated time that was made for this question is over. So I hope every one of you have tried it. So those who have not tried, just match it with the solution. So here we are going to discuss another important problem solving strategy or problem solving technique, you can say. And that important strategy is Rolle's theorem. So I hope that every one of you know Rolle's theorem in calculus. So those of you who don't know, so I'm just repeating it for once. So if fx f of a equals to 0 and f of b equals to 0, or we might not say this is a much weaker condition. So the much stronger condition is if f of a equals to f of b, then there exists C belongs to open interval a comma b such that f dash c equals to 0. So this is Rolle's theorem. So it states that if f of a equals to f of b, it means that the functional values at 2 points is equal. So there exists a C in between a and b such that f dash c equals to 0. So the function must be differentiable. So if it is not differentiable, then your proof will not work, because suppose I take the function greatest integer function of x. So greatest integer function of x is not a differentiable function because it is not at all a continuous function and hence it cannot be differentiable. So you can see that f of 1.2 is 1, f of 1.3 is 1, but in all values f of 1.2 to 1.3 the value is 1. So therefore at no point the derivative is 0. This is because the function is not differentiable. So remember that the function for Rolle's theorem that you are applying must be differentiable. That's a must. So how can we apply Rolle's theorem to this problem? Let's get back to our original equation and write it. So it is given that fx equals x minus a whole cube plus x minus b whole cube plus x minus c whole cube. Okay, so as I said that the intuition is very much important. So if this equation has two real roots, say this equation has at least one real root, or say this equation has at least two real roots, or I suppose that if this equation has any real root, then what can we say? Then we can say that f of alpha equals to 0 and another real root f of beta equals to 0. Okay, because alpha and beta are roots. Now this function is differentiable function. You can always see that this function is continuous, differentiable and everything. So there must be a point for which f dash c is 0. So f dash c is become c minus a. So I take 3 common, c minus a whole square plus c minus b whole square. So I don't take it c, as already c is taken, so I take d. So d. So d minus b whole square plus d minus c whole square. Now you see that these all are real numbers, and the product of and the sum of squares of real numbers must be 0, which means that a equals to b equals to c. But we cannot have a equals to b equals to c. This is because a, b, c were given arbitrarily real numbers. They were just arbitrarily chosen real numbers, and hence we see that this condition fails. The Rolle's theorem fails to hold here. I again repeat that I think that I am not very clear with this concept, so I again repeat that this is the equation given and these are the two roots and I need the derivative. So what will I do? So I just assume that the derivative is 0. This is because that is by the statement of Rolle's theorem. So Rolle's theorem says that this must be 0 at some point between alpha and beta, but due to the sum of 3 squares, which is always positive for real numbers, as we know, this thing cannot be 0 for all real numbers between alpha and beta. So we conclude that this equation has no real roots. So the number of real roots is 0. So we see that how did we apply Rolle's theorem to solving problems like these? So to solve problems like these, the general strategy is to just assume the roots. So remember these 3-step strategy, that you must assume the roots to be something and then show the contradiction by Rolle's theorem. First, the intuition is very important. So what I had is that this was a very increasing function. You can already verify it from the derivative. So that was the main intuition behind the problem, and that was the main thrust that the problem needed to be solved. So that's why these questions are very beautiful. So I recommend you to remember this strategy and try problems of these types from test of mathematics. So now we will get down to the second question of test of mathematics at the 10+2 level. So the second question that states is, so this is the second question for today. Px is a polynomial of degree 5 with real coefficients, then the number of real roots of Px is. So what is said that the Px is a polynomial of degree 5 with real coefficients, so the coefficients of the powers of x must be real. Then the number of real roots of Px is 1, 2 or 4, 1 or 3 or 5, and D is none of the above. So I give you exactly 2 minutes to try and solve this question. This is because that's the time in which you require to solve this problem in the I.S.I exam. Okay, so the stipulated time that was meant for this question is over, and now it's my time to try the hands to the question. So I hope that many of you can solve this question, and if you can't, then I think that you lack the essential concept that is necessary to solve this question. So I am here right now to give you that. So now let me find a duster to rub the board. Yeah, I got it. So now let me tell you a very interesting and important fact. So if P is a polynomial with real coefficients, so now what I am doing is I am dealing a polynomial with real coefficients whose degree is an odd number. So what did I say? Let me repeat it again. I said that P is a polynomial with real coefficients. P is a polynomial with real coefficients whose degree is an odd number, has at least one real root. So many of you I think have got this statement, and if you can't, just rewind this. I am just repeating again that if P is a polynomial with real coefficients with odd degree, then it has at least one real root. Okay, so this is a very important fact that I will require later. So it has at least one real root. Now what does the question suggest? We will solve the question by this trick in a few seconds. Just I need a few seconds to solve this question. So if P is a polynomial with real coefficients, then what can I say? That suppose P has a degree 5, so it's given in the question. So P has at least one real root. So one real root is a possible case. So let me write it on the board that one real root is a possible case. Now I say that it has at least one real root. It can have more than one real root also. So let us assume that it has more than one real root. And let the real root be x minus alpha times x minus beta. Now if I divide px by x minus alpha and x minus beta, there is a quadratic term. What I get as a quotient? The quotient is a third degree polynomial. Observe that the third degree polynomial again has one real root, and two real roots of px along with one real root gives you three real roots. So again, three real roots is a possible case. Now since a fifth degree equation cannot have any roots more than 5, it is extremely possible that all the roots of the equation are real. And since the degree is 5, so 5 real roots is also a possible case. So one real root is a possible case, 3 real root is a possible case, and 5 real root is a possible case. So the number of real roots is 1 or 3 or 5. So if I tally this with the tomato book, then what is the option number? So it's option number C. So I hope that you have noticed the elegancy in this method that I used just by a simple fact. Using this simple fact, I can save time and solve such questions very easily during the exam. So hardly, if I had to think and not just tell loudly, just I need to do for making you understand this, the thinking basically requires half a minute, that is 30 seconds. And if half a minute is saved out of 2 minutes, then you can apply those 1.5 minutes left for other problems extra. So I request you to go through these tricks very thoroughly, and not only going through these tricks will help, knowing through these facts will help. These facts must be entitled for proper use. These facts must be meant for proper usage. Suppose you learned a trick today, you learned this trick, you learned this fact, and you don't practice questions out of this trick, or you don't practice questions out of this fact, then I am very sorry to say that it's our natural tendency that we will forget things that are not in practice. And as you have all heard about the proverb that practice makes a man perfect, so you should keep practicing the tricks that you will learn in this video and apply it to later problems. Because unless you apply it, it will all go in a waste. So let me get to the third question of this video. So I need to find the question. Okay, so I am going back to the third question, and this is a very interesting question that is to be mentioned. So I need my tomato to solve the question. Okay, so it's given as 50C0 into 50C1 plus 50C1 into 50C2 plus plus 50C49 and 50C50. Is number A. 100C50, number B, option B, 100C51, option C, 50C25, and option D is 50C25 whole square. So this tells that the value of this, so what is the value of this? So the value of this is one of the four options, and you need to find out what is the correct option. So I give you just 2 minutes, the stipulated time, to solve this question. Okay, so the stipulated time that was meant for this problem is over. So we will explore another new trick to solve this problem. And in fact, for this problem, I will solve it in two ways. And I recommend you to find whichever way you find easier to perform that in the exam. So let me just rub the board. So the first way and the first trick today we are going to know and today we are going to learn about is the Vandermonde's identity. So Vandermonde's identity. So Vandermonde's identity. So what does this identity say? This identity says that, just wait a bit. So today we are going to learn about the Vandermonde's identity to solve this problem. Okay, so this is the Vandermonde's identity, otherwise, as I was saying. So it says that if you have m plus n objects and you have to select k objects out of that, it means it is same as choosing MC0 objects, MC1 objects and choosing k minus r objects from the rest. So you can easily verify this problem. So what I use is, I use a story proof. What is a story proof? I will just construct a story to prove the left side and the right hand side. Now suppose you have a box of balls. You have two boxes of balls and what you do is you need to pick up exactly k balls from both the boxes. How can you pick up exactly k balls? One thing you can do is very easy. You just mix the balls from both the boxes. Now if you mix the balls from both the boxes, what happens? The number of total balls is m plus n and you need to select k balls out of m plus n. So the number of selections is m plus n choose k. Now you can do another thing. Just select r balls out of m box and just select the k minus r, because our target was k. So k minus r balls from the other box. So I hope it is clear. You choose 0 balls from this and all the balls from here. Either you choose 1 balls from this or all the balls from here. You choose 2 balls from this or all the balls and k minus 2 balls from here. 3 balls from the m box and the k minus 3 balls. And this, if you do on this, then it can be compressed and written in this. And in both cases, what you are doing is, in both cases, you are just choosing the k balls from both boxes containing m balls and n balls. Okay, so this is the famous Vandermonde's identity, and the technique I used in proving Vandermonde's identity, remember it's a very important technique that is known as story proof. So I just constructed a story to prove this statement. Now how do I exploit the story and the Vandermonde's identity to solve this problem? So the given expression here is, according to the book of Tomato, 50C0 50C1 plus dot 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 plus 50C49 and 50C50. And we know, what do we know? And what do we see? 0, 1 plus 1 and the next term will be, what can be the next term? The next term is 1, 2. The next term is again 2, 3 and here it goes from 49 to 50. So by Vandermonde's identity, what I can do? I can just, so to apply Vandermonde's identity, I need to convert it. Now you see that 1, 0, 2, 1 are not in the form of r comma k minus r, isn't it? So to convert it, what technique do I use again? We know the very well-known technique, that is NCR equals to NCn minus r. Applying that technique, I can rewrite this as 50C50 into 50C1 perhaps, 50C49 into 50C2 and so on. And by Vandermonde's, now I can apply Vandermonde's identity. This is because all these terms have the same sum. 50 plus 1, 51, 49 plus 2, 51, and hence I can apply Vandermonde's identity here. And if I apply Vandermonde's identity, then what do I get? I get is 100C51. So I hope that you have understood the utility of Vandermonde's identity and the utility of story proof. I request you to just rewind this part again and see it. So what was Vandermonde's identity? The Vandermonde's identity says that m plus n choose k is summation of m choose r plus n minus k choose r. And what was the story proof I gave? So repeating the story proof again, I have m balls and n balls. I need to choose r balls from, I need to choose k balls from there. So this is what the Vandermonde identity states and the story proof, and I am telling that many subjective problems in Olympiads, I.S.I, CMI entrance examination require this identity as their to solve their problems. So remember this identity, and as I said, don't just remember, solve problems using that identity and things will be clear to you, things will be visible to you. So the thing with the maths is you must make things visible in front of your eyes. Like I could solve the problem using Vandermonde's identity, I could construct a story on my own. This is because the Vandermonde's identity was clear in front of my eyes. Or any expert could solve this problem with Vandermonde's identity because the Vandermonde's identity would be playing in front of their eyes. Just like a story plays or a story goes in front of your eyes. Just like you try to fantasize things. So likewise, what do you need to do to get into the deep core of mathematics? You just need to practice problems based on the concepts that are being discussed. So the last problem for today that I have selected is a very interesting problem. The number of ordered pairs of positive integers with GCD 6 and x plus y equals to 90. So it says the number of ordered pairs the options as per given in the tomato book. You can see the options are 15, option B is 14, option C is 8 and option D is 10. So this is the question. So the number of ordered pairs with x and y belongs to natural numbers, GCD 6 and x plus y equals to 90 is 15, 14, 8 or 10. So again I try to give 2 minutes for this question. So just think and try solving this. After you cannot solve, I am always there to solve this. Okay, so the 2 minutes time have expired and now I will discuss this question. So those who have tried and couldn't solve, please look at it, and those who have solved, just tally with the answer that I am giving. You might get a new approach. So the approach for this question is very simple. So x comma y, GCD of x comma y is equals to 6 is given. And so 6 divides x and 6 divides y. So 6 must divide x since the GCD is 6 and 6 is a divisor. 6 must be a divisor because that is the definition of GCD, that is greatest common divisor. So x can be written as 6m and y can be written as 6m. Therefore GCD of x comma y is equals to 6 into GCD of m comma n. where the GCD of m comma n must be 1. We just have seen that the GCD of m comma n must be 1. So if x plus y equals to 90, so I just replace it by 6m and 6n and I just take 6 common. So m plus n equals to 90, which is equals to 15. So I need to find the number of solutions of m plus n equals to 15 where the totality is not, where the GCD of m comma n is 1. Now how do I find the number of solutions m plus n equals to 15 where the GCD is 1? I'll just show you a trick to find it. Now for the trick for two real numbers is quite simple. The toughest part will when you get more real numbers, and that is a special trick which will be taught later on. So what can be the solutions? 1 15, 2 13, so 1 14, sorry, 2 13, 3 12, 4 11, 5 10, 6. So I'm just listing out the possible values of m and n. 6 9, 7 8, 8 9, 9 10, 10 11, 11 12. Sorry, I am just listing it out in a very wrong order. So 7 8. So after 8 it will become to 7. I'm just sorry, I just listed out in order. 7, then 6, then 5, then 4, then 3, then 2, then 1. Okay, so now if from these lists, so I hope that I am very clear in representing you the list. So now from this list I need to find those with GCD 1. So how many are there? This is an admissible player. GCD of 2, 13 is 1. GCD of 3, 12 is 3, therefore not admissible. GCD of 4, 11 is 1, but GCD of 5, 10 is 5. GCD of 6, 9 is 3. GCD of 7, 8 is 1. GCD of 8, 7 is 1. Similarly 9, 6, 10, 5, 11, 4 GCD is 1. 13, 2 GCD is 1 and 14, 1 GCD is 1. Okay. So how many solutions are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 solutions in all. So the actual value is 8 solutions, and hence the correct option is C. So what did I make? Do with the problem. So I just analyzed the problem and I just wrote the number of solutions explicitly. This is because this can only be the number of solutions. So and what did I do it later? So I knew that GCD of m comma n is 1. I just included those with GCD 1, and that was the end of the problem. So as you can all see that, as you have all seen that today in this class we have learned a very interesting tricks, and we have given very interesting tips for problem solving. So the fact is that you have to analyze these tricks on your own. You have to utilize these tricks in solving other problems. From test of mathematics, I.S.I past papers, those are very important for your exam. Remembering, just seeing these tricks once in a video is not at all sufficient. After seeing this, you must go and just sit down. So mathematics doing without pen and paper, doing mathematics without pen and paper is just, as you can say, that throwing pebbles in water without any hope. So the fact is that you just can't do or learn mathematics without sitting with a pen and paper. So right now you must go and just work out on these types of problems using the ideas I have discussed in this class. So if you have worked out, if you have checked the solutions, then you will be confident, and again you will need to rewind the concepts again. So just do these process steps and I am sure that you will succeed. So goodbye till then, best of luck for your exams, and thank you.